Hello Form 3, this is a slightly longer video today just to cover the ideas for today's work and Friday's exercise 18.2. This video lesson will look at three important ideas: how to identify types of correlation or connection between sets of data, how to draw a line of best fit, and how to find the equation of a line of best fit. I'll be looking at an example that's on page 180 of your textbook and trying to help you with exercise 18.2. So we start with the idea of correlation. Correlation is just an idea that relates to whether two types of data have a connection or not. So we might be interested in your mass and your height and whether there's a connection between these two, or your intelligence and your shoe size. Are these things related or not? Or how many days absent you are at school and how that might affect your school grades. When we're looking at correlations, there's actually three very important types that you need to be able to spot. So I'm going to show you them now. And we'll see that on the left, there is what we call a positive correlation. That's when they're grouped together in such a way that they seem to be moving upwards together, so they're sloping upwards. And that can be strong or weak, where they're kind of close together but not quite as strong as on the left. And actually mass and height would be an example, where there's quite a strong connection between how tall you are and then how heavy you would be. So mass and height would be an example of a strong positive correlation. So we can move that to that category. The dots, points are moving upwards, but no correlation would be when the points are just scattered out, as we can see in the middle. And in fact, there is no connection between your intelligence and your shoe size, so we can move that to the middle. And we call this no correlation or zero correlation. And the last one would be a negative correlation. So actually, if you have a lot of days absent, if that goes up, your grades go down. So we can see that there's a sloping down of the points that are grouped together. And again, that can be weak, or on the right, very strong. So you need to be aware of these three types of correlation: positive, no correlation, or negative correlation. And they'll be covered in the exercise today. If we do have a correlation, positive or negative, then we look to try and estimate some values based on that information. And we do that using what's called a line of best fit. So let's look at that now. So you can see here I have an example drawn from exercise 18.1, our maths and English students tests. And we can see there seems to be quite a grouping here. Pupils who do well in English, for example, scoring 6, seem to be able to get 6 in maths, or in fact someone's got 6 and then 7 in maths. People who don't do well in English tend to not do well in maths. So there's a fairly strong positive correlation in this data. Remember, it's positive because it's sloping upwards. And what we want to do then is to draw a line that we call a line of best fit through these points to try and approximate all of this information in just a straight line relationship. We call that a line of best fit, and it might look something like this. So you'll see that I've drawn that through quite a number of points. There might be some trial and error as you draw this line, but there are some important things you must make sure that you do. So first of all, you should try to get through as many of the points as possible. And actually, I've managed to draw that line through 5 of the points. And the other thing that you should try to do is make sure that there are as many points above as there are below the line. So really trying to get it in the middle. And you can see actually that our line looks pretty good. I want you to make sure that today you draw that all the way through to the y-axis. So for this particular graph, you'll see that our x-axis is English and our y-axis is maths. But you'll take some time just to think about the line, and it doesn't have to be perfect, and it won't be the same as another person in class, but you do the best that you can to draw a straight line, and you'll be okay. The other thing that you need to do today is to find the equation of this line of best fit. Now we know that any straight line has the equation y equals mx plus c. That's something from our previous study of straight lines. So that will be our starting point today. Y equals mx plus c, where the English will be our x-axis, the horizontal is our x-axis, and the maths is our y-axis. And the gradient is m, and the y-intercept is our c. So let me just label these axes. x and y to be clearer. And all we're going to do is find the equation of this blue line. And that's why it's important that you draw the line nice and long either side of the points. The line is really replacing the points now. So we can see the y-intercept. That will be where the line hits the y-axis, and that is the point 0, 1. It's here. So from that we can infer that the y-intercept, c, is 1 for this line. Then we need to find the gradient. We can do that by choosing 2 points, drawing a little triangle like this, and then working out the vertical and horizontal distance. So the horizontal distance is 1 from 3 to 4, and the vertical from 4 to 5 is also 1. Our gradient is the vertical divided by the horizontal. It's going to be positive because the line is sloping upwards. It'll be 1 over 1, which is 1. So we have our gradient, we have our y-intercept. We can write down the equation of this line of best fit. That will be y equals 1x, but we don't write the 1, we just write x. So it'll be y equals x plus 1. And that's the equation of our line of best fit. We could also see that slightly differently if we don't use x and y, but we use English and maths. So we can see that maths is the y-axis, so you could say that your maths score just equals your English score plus 1. And that is true for any of the points that are on the blue line, and it's fairly true for points that are close to the blue line as well. So you're going to look at doing that today in the exercise. It's important you draw that line carefully, and then you find the equation of that line. It may differ from someone else in class, but not wildly, so you'll be okay. Quite difficult though, so take some time, study this video, study the example before you try exercise 18.2. Any help today is available from your teacher on the class teams page, or from myself and Mrs. Mason on the All Form 3 page. And I will put out another video today which will look at some examples from the exercise, maybe give you a bit more help, particularly looking at negative gradients. Good luck.